Welcome to a lesson with Dr. Powell. Let's take a look at a vector function, and we're going to find the unit tangent vector as a function of t, and we're also going to find the unit tangent, the unit normal vector as a function of t as well. So, looking at this, notice we have a cosh of t and a sinh of t. These are hyperbolic trigonometric functions. And you can go to my video series for Calc 2 to see how these work in their derivatives. Okay, now what we do to remember unit tangent vector is simply the velocity vector, but then you divide it by its length to make it of length 1. So this we compute by just taking the derivative component-wise per component. Here, derivative cosh is just positive sinh. This is just 1. Derivative of this is negative cosh t. Okay, then we divide by its length. Okay, so that would be the square root, and then here we have sinh squared of t plus 1 plus cosh squared of t. Now there's an identity between sinh and cosh. It comes from the idea that that cosh and sinh parameterize not a circle, but the unit hyperbola that faces in this way, that opens in the x direction. And so we get cosh squared of t minus sinh squared of t is equal to 1, which means that cosh squared of t is equal to 1 plus sinh. And notice that we have sinh squared plus 1 right here. So that's just equal to cosh squared. So this is cosh squared, that's cosh squared. So really under the radical is 2 cosh squared. And we're taking a square root of that. So it looks like that all of this put together underneath the, so we're take the velocity vector, and then what we're going to do to it when we divide by its magnitude, we end up simply getting the square root of 2 times cosh of t. Okay, and that's going to be equal to the unit tangent vector as a function of t. We're successful at finding t. Now let's find n. Now, to compute n, we just take the derivative of the unit tangent vector and with respect to t, and then we divide it by its length to make it a unit. That's how we find n. So we just take what we have right here and take its derivative. So let's kind of simplify this a little bit here. Divide this into each component, because notice that we have a function of t out here that we're dividing by. So we got to put that in before we take a derivative by per each component. So we end up dividing cosh into there. In the first component we have, and maybe we can pull the 1 over square root of 2 out here. So then the first component we would have tanh of t. Then in this component we'd have secant of t, and the last one, cosh divided by cosh, is just 1, so negative 1. Okay, so so that's what the unit tangent vector looks like. Now let's take the derivative of this. So then we're going to compute the derivative with respect to t of the unit tangent vector, which is what this is. Constant stays out there. And then, we get, for the derivative of tangent, we get simply secant squared of t. And the derivative of secant, so the derivative of cosh and secant are just a negative of what you expect, but the derivatives of the others are kind of what you would expect here. Secant would be negative secant of t, tangent of t, and then take a derivative of -1, it's to 0. Okay. All right. So we're almost done to find n. We have this, but then we just have to take this and divide it by its length. And then we're through. So we got to divide all this by its length. Okay, so we can just take this on the outside here, and then just take, so this scalar, this number right here multiplying in, can just stay there, and then you just find the length of this part. So the square root of each one of these things squared. So secant the 4th t, that's a 4th power, plus secant squared t tangent squared t. And then in looking in this, we can factor out a secant squared. Let's do this off to the side, secant squared. And then we're left with secant squared plus tangent squared t. And all of this is underneath the square root. Okay, now right here, secant squared plus tangent squared, there's an identity for that, and it comes from the identity we already have, cosh squared of t minus sinh squared of t is equal to 1. And let's see, how can we get tangent? Secant, we'll just divide by cosh squared here everywhere. We end up getting 1 minus tangent squared. So just taking this line, dividing by cosh squared is equal to secant squared. So notice if you add the tangent over, we end up getting that secant squared plus tangent squared is equal to 1. Very nice. So that's 1. And so then the square root would simply be secant of t. Okay, so this whole bit right here is just simply secant of t. Okay. And so let's just put that in right here, secant of t. And notice that those, these cancel right here out. So you just divide this in. So divided this into each part, and you end up getting, so after dividing it in, let's just do that right away. Just divide this in. So when it divides in, it's going to take that away. That's squared. It's going to take this away. And that's gone. So we end up getting, for the unit normal vector, just this right here. And we'll rewrite it as, so that negative here applies to that bit. So just secant of t minus tangent of t, 0. And so this would be the unit normal vector. We had the unit tangent vector. And we've been successful at computing those for our function, r of t. Thanks for watching.